Hi, Integrated Math 1 students. Today we're going to be working on Lesson 51, which is modeling quantities. So the goal for today, or objective, is I will be able to compare units using proportions. This is kind of something we've worked on in 7th grade. The big idea here that I hope you remember, but we will emphasize and reteach today, is the idea of cross multiplying. Let's say we had two fractions. Let's say that 2/5 is equal to something over 10. I know you could do this in your head, but how do we figure this out when it's more complex? You could cross multiply. So 5 times x is 5x. 2 times 10 is 20. Divide both sides by 5. So x is equal to 4. And that was what your prediction was, right? So we use cross multiplying to help us solve proportions. Okay, so let's have students write this down. Let's have the teacher please pause the video here. Alright, great. So students should have written this down. Here's some vocabulary I want you to go through. So ratio, write these down as I talk about them too, because you'll be writing this whole thing down. Okay, a ratio is a comparison of two numbers by division. So for example, I could say the ratio of boys to girls at this school is we have 10 boys for every 9 girls. So this is a ratio, 10 over 9. You're like, well, that's an improper fraction. Well, yeah, but I'm trying to emphasize there are 10 boys to every 9 girls. So we couldn't really make a comparison if we were to write this as 1 1/9. It'd be a little bit confusing, so we don't really do that. Okay, so I'm going to actually erase it so you don't copy that. Next thing I want to talk about is proportion. Is an equation that states two ratios are equal. I did that on the last slide. When we do that using cross multiplying, we solve them. A scale is the ratio of any length in scale drawing to the corresponding actual length. So for example, like when you have a picture on a computer, right, and you want to put it in your presentation. Let's say it was just this little small picture like this, okay? And you wanted to make the scale bigger, so you zoomed it out and you made it twice as big. Well, that's a scale. We kept the picture to look the same, but we made it stretch out to scale, so it doesn't look like it's squished or stretched. Okay, scale drawing is the same idea. The scale drawing is a drawing that uses a scale to represent an object as smaller or larger than the original object. So just like scale has, or the previous one is the ratio of any length in a scale drawing to the corresponding actual length. So over here we took the original, which was, let's just say the original original was 1 and we doubled it to 2. Same idea here for the scale drawing. Dimensional analysis is a method of manipulating unit measures algebraically to determine the proper units for a quantity. So that's just what we're going to be doing today. And then rate is the comparison of two quantities with different units. We'll talk about that today. Okay, so let's have the teacher please pause this video. This is going to take about a couple minutes for students to write this down, so let's have students write the slide down. Alright, students should have written this down, so let's do an example here. I'll show you one example, and then we'll do a couple more together. So it's a little small here, hopefully you could see it, so if not, I'll just read it out loud. So, big idea. We have a totem pole here. A totem pole that is 90 feet tall casts a shadow that is 45 feet long. Okay? At the same time, a 6-foot tall man casts a shadow that is X feet long. The man at the totem pole are both perpendicular to the ground, so they form right angles with the ground. The sun shines at the same angle on both, so similar triangles are formed. Okay, so let's say we had the sun shining in the corner here, right? Let's say that was the sun. We're trying to figure out how big is the shadow of the man. So we could use, this is a classic use of proportions. We know we could have the same ratios because we have the same type of shadow. So write a ratio of the man's height to the totem pole height. So the man's height is 6 feet, and the totem pole's height is 90 feet, right? Tall. It's a very tall one. So that's our ratio of the man's height to the totem pole's height. And then we could say the man's shadow to the totem pole shadow. Well, the man's shadow we don't know. That's the question here. So that'll be our x. And the totem pole shadow is 45. Right? So some of you might be already guessing and thinking, oh, I know what the answer is here. Let's just keep working this out. So now we're going to take the man's height, which is 6 feet, over the totem pole's height, right here. I'm just going to copy that right here, which is 90. And then we have the pole's shadow, which is 45. We don't know what the man's shadow is, but we could kind of get an idea here. Now, we could look at this a couple ways. We could either cross multiply, or we could just kind of guess here. So I could think, like, for me to get from 6 to x is kind of hard, but I know that to go from 90 to 45 I divide by 2. So I think, what's 6 divided by 2? That's 3. I'm just going to put this on the side, okay? So one way to do this is you could cross multiply. You could say 90 times x is 90x, and then 6 times 45 is 270. Divide both sides by 90. So we get x is equal to 3, right? And isn't that the same answer we have right up here? So you could cross multiply, or you could do it in your head. We could solve by cross multiplying. Okay, I'm going to put that here. Both sides. And then we solve the proportion. The man's shadow is 3 feet. Okay? Alright, so that's the big idea of what we're doing. Let's have students write down, well, I don't want you to write everything down. Let's have you write down just how we set up the problem here and how we solve the problem here, okay? You don't have to really do too much. And then also you can write down this circled part. I want you to draw a picture, that way you have something to go to in your notes. Let's pause the video here for students. Alright students, you should have written this down. So let's go try another couple of examples here. Okay, so over here we have another example. And we have steps here. So let's have the students pause the video again, or I'm sorry, the teacher please pause the video. Let's have students write this down, the steps here. This is kind of the big idea of how we did things on the last problem. Those will be our steps. Please pause the video here. Alright, so we have a problem here. The problem is saying that the flagpole casts an 8-foot shadow as shown in the table. At the same time, the oak tree casts a 12-foot shadow. How tall is the oak tree? So we have some idea here of the flagpole. We have the length of shadow and the height. So I can make a proportion of shadow over height, and I know it's going to be 8 over 20, which is like, I could simplify that as 2 over 5, right? So the question is, how tall is the oak tree? So I could work that out by taking my original ratio of 2 to 5, meaning the shadow is going to be a length of 2 for a height of 5 feet. So if I know that my oak tree has a shadow of 12 feet, that's going to go in the numerator, right? And that's over x. So I'm going to do the cross multiply thing. So let's have the students, or let's pause the video here just for about 30 seconds, have students cross multiply and solve what the answer is. Okay, so students, you should have cross multiplied. So 2 times x is 2x. 5 times 12 is 60. Divide both sides by 2. So x is equal to 30, right? So oak tree is 30 feet tall, right? That's how we do the goalpost now. So if I know that the oak tree is 30, how tall is the goalpost? So again, you're going to set up the proportion. You have two fractions equal to each other, and you're going to cross multiply. Okay, so let's pause the video here for students to attempt to do this. Alright students, so we should have taken our original proportion, the shadow length of 2 over the height of an object is 5, is equal to our goalpost shadow length, which is 18, over our goalpost height, which is what we don't know. We're going to cross multiply. So here we go. 2 times x is 2x. 18 times 5 is 90. Divide both sides by 2. We get x is equal to 45. Okay? Hopefully you're getting this, right? You're getting the hang of this? Now the last one, what is the length of the fence's shadow? So we know this one is going to be 90, right? Did I put that right? 90? No, I put 45, I'm sorry. 45. Okay? So fence length, right? It's giving us kind of a weird answer, 6.5. So not to worry, we're going to do the same thing 2/5, but it's not giving us the shadow length, which means the numerator. We got to figure that out. So I'll put that in blue here. We are given the height of the fence. So let's predict what this could be. Let's cross multiply. 5 times x is 5x. 2 times 6.5 is going to be 13. Divide both sides by 5. We could get x is equal to 13/5. Or we could say it's also equal to 2 3/5 feet. Okay? So that's the idea here. We are just using proportions to solve. Okay? Alright, let's do one last one. I think we're getting the idea here. So I would like students to look at this one as a group. You're going to be solving this. Convert 950 US dollars to British pounds sterling. Use $1 US equal to 0.62 British pounds of sterling. Let's pause the video here. Let's have students do this for about a couple minutes and I'll come back. Alright, so you should have worked on this problem. This is what I would have done. So we need to create a proportion first. So we're talking about two different currencies. We're talking about US and British pounds. So what will our proportion be? Well, it gives us an idea. 1 over 0.62. Okay? That's our proportion. Can't really solve or simplify that anymore. We could try to simplify more, but that's okay. And we're going to use that now. We're going to use our original proportion of 1 to 0.62. The numerator is going to be US. The denominator is British pounds. Okay? And so it's asking how much is $950. Okay, so 950 is going into the numerator. The denominator we don't know. So we cross multiply. 1 times x is x. 0.62 times 950 is 589. Okay, and that's 589 British pounds. And we don't need to isolate this anymore. X is by itself, so that's our answer. Okay, pretty easy and straightforward. So again, the big idea is set up a proportion, cross multiply. This is easy once we figure out how to set things up, but it's hard to set it up at first. So what I'd like you to do now, we're not going to do any more problems today because I know it's Halloween and I know you want to get to work and you'll probably socialize and stuff. So let's have you work on workbook page 3. I'm not assigning any new AMs today because I know tonight you're going to be hanging out, doing your stuff, trick-or-treating and stuff. So let's have you work this out here as practice, and then that's it for today. If you are done early, please work on any other AMs or AM 2.0s. Alright kids, have a great day. Stay safe out there. Take care. Bye.